Control of batch processes. What is batch processes? A batch process is generally considered one that acts on a discrete amount of material in a sequential fashion. Probably the easiest way to describe a batch process is to compare and contrast it to continuous process, which is more common in industry today. The examples discussed below are specifically geared to continuous and batch versions of chemical process, but these same concepts apply to a diverse range of industries. Batch manufacturing techniques can be found in wine, beer making, food and beverage production, mining, oil and gas processing, and so on. A continuous chemical process usually introduces a constant stream of raw material into the process, moving the material through a series of vessels to perform the necessary chemical steps to make the product. The material might pass through a fluidized bed reactor to begin the chemical reaction, pass through a water quench vessel to cool the material and remove some of unwanted byproducts, and finally be pushed through a series of distillation columns to refine the final product before pumping it to storage. In contrast, a batch a chemical process usually charges the raw materials to a batch reactor and then performs a series of chemical steps in that some vessels until the desired product is achieved. These steps might chemicals these steps might include mixing, heating, cooling, distilling, and so on. When the steps are complete, the material might be pumped to a storage, or it may be an intermediate material that is transferred to another batch vessel where more processing steps are performed. Another key difference between continuous and batch processes is the typical running state of the process. A continuous process usually has a short startup sequence and then it achieves steady state and remains in that state for days, weeks, months, and even years. The startup and shutdown sequence are often a tiny fraction of the production run. In comparison, a batch process rarely achieves steady state. The process is constantly transitioning from state to the state as the control system performs the processing sequence on the batch. The third significant difference between batch and continuous processes is one of flexibility. A continuous process is specifically designed to make other products is often quite expensive and uh, difficult to implement. In contrast, a batch process is initial, initially designed to make a large number of products easily. Processing vessels are designed to handle a range of raw material. Vessels can be added or removed from the processing sequence as necessary, and the reactor jackets and overhead piping are designed to handle a wide range of conditions. The flexibility of the batch process is an advantage and disadvantage. The inherent flexibility allows a batch process to turn out a large number of very different products using the same equipment. The batch process vessels or programming can also be easily configured to make completely new product with a short turnaround. However, the relatively small size of batch vessels generally limits the throughput of the product, so batch processes can rarely make the volume and efficiency large of a large continuous process. This is why both continuous and batch processes are extensively used in manufacturing today. Each has advantage and serve specific market needs. Controlling a batch process. From a control system perspective, the design of continuous plant is usually quite straightforward. The instruments are sized and selected for the steady state conditions, and the configuration normally consists of a large number of continuous proportional integration controllers that keep the process at the desired steady state. The design of a batch control system is another matter entirely. The field instrumentation will often face a large dynamic range of process conditions, and control system must be configured to handle a large number of normal, transitional, and abnormal conditions. In addition, the control system must be easily configured to address the changing process vessel sequence, type changes, varying products requirements, and so on. The more flexible a batch process is, the more demanding the requirements on the control system. In some cases, a single set of batch vessels might make 50 to 100 different products. Clearly, such programming complexity poses quite a challenge for the automation professional due to the different that batch sequence posed. Most batch processes were run manually for many years. As sequential controllers become available, simple batch systems were functionally automated when limited sequence programmed into programmable logic controllers and drum programmers. Fully computerized system that could deal with around that time. Several proprietary batch control products were introduced. Unfortunately, each had its own method of handling the complexities of batch programming, and each company used different terminology, adding to the confusions. The need of a common batch standard was obvious. The first part of ISA 88 batch control standard was published in 1995 and has had a remarkable effect on the industry. Later, it was adopted by the American National Standards Institute. It is currently named ANSI ISA 880001 2010, but it is still broadly known as S88. It provides a standard terminology as internally consistent set of principles and a set of models that can be applied to virtually any batch processes. ANSI ISA 180001 can a discrete control system mainly has discrete sensors and actuators. That is, sensors and actuators that have one of two values, either off on or open closed. Though a ladder diagram LD is primary language of a discrete discrete control. The study trend is toward using the IEC 61 131 C, formerly 1131 3 standard.